Welcome. Now, in this class, we shall be looking at the rules guiding differentiation, or simply put, derivative rules. Rule 1. The derivative of a constant is equal to 0. That's our first rule. What do we say? What do we mean? If y is equal to c, where c is a constant, then it means that dy dx will be equal to, this is as good as mine, 0. Let us try one example. If y is equal to 20, for instance, this implies that dy dx will be equal to 0. Remember, your constant can be an integer or a real number. An integer in this case of a whole number like 20, or a real number where it can be made up of an integer plus decimal points. So if we have 20 for, as we have in this example, dy dx of 20 is 0. dy dx of 1000 is 0. dy dx of 0.001 is 0. dy dx of 1 million will still give us 0. Okay. Rule 2. If y is equal to x raised to power n, then dy dx will be equal to n times x raised to power n minus 1. This is a very simple rule. What we do here is to use the power of x to multiply its coefficients. In this case, the coefficient of x in this case is 1. So we use the power of x to multiply its coefficients and then subtract 1 from its power. Easy, right? Let's do an example. If we have that y is equal to x raised to power 4, then this implies that dy dx is going to be equal to, bring down the coefficient, the power of x multiplies coefficient, 4 times x raised to power 4 minus 1, based on this rule. So we have dy dx will be equal to 4x raised to power 3, or 4x cubed. Let's try another example just for us to understand better. If we have that y is equal to 5x raised to power 3, our rule says use the power of x to multiply the coefficient of x. So we're going to be saying 3 times 5x raised to power 3 minus 1. So dy dx is going to be equal to 3 times 5 raised to power 3 minus 1. Please, this dot we see here, or this dot you can see here, stands for times. You could either use a dot like this to signify times, or you could use the x sign to signify times. So dy dx in this case is going to be equal to 3 times 5 is 15, and 3 minus 1 is 2. So that will be dy dx will be equal to 15x squared. One more example. If we have that y is equal to 4x to the power 4 plus 5x to the power 3 plus 7x squared plus 13x plus 12, what is dy dx? Now, this example is just a way of trying to show us that differentiation is linear in nature. This example shows the linearity of differentiation as a function, as an operation. So dy dx of this particular equation is going to be equal to, we'll handle the first power of x separately and then add it to the next one. Do that one, add to the next one, and that's how we are going to proceed. So for the first one, we have 4 times the coefficient of x, which is 4. So we have 4 times 4x to the power 4 minus 1 plus 3 times 5x to the power 2. That's 3 minus 2. That's 3 times 5x to the power 3 minus 1 plus 7 times 2x raised to the power 2 minus 1 plus 13 times x raised to the power 1 minus 1 plus, remember, we said the differentiation of a constant is equal to 0. This is a constant, 12. Therefore, divide the x of 12 will be equal to 0. So that will be plus 0. So divide the x, simplifying that, what we have up there, what we have here, divide the x will be equal to 4 times 4 is 16. X, 4 minus 1 is 3. So that will be 16x raised to the power 3. Plus, so that will be 5 times 3 is 15. 3 minus 1 is 2. So that will be 15x squared. Plus, 7 times 2 is 14. 2 minus 1 is 1. So that will be 7 times 2, 14. That will be 14x plus 13 times x to the power 1 minus 1. Remember, 1 minus 1 is equal to 0. Anything raised to the power 0 is 1. So that will be 13 times 1, which is plus 13. Easily done. Okay, so let us look at rule 3. Rule 3 states that if y is equal to sine x, then divide the x will be equal to cos x. Please take note of this and write this down, please. Take note of this because we'll be using this to work later. Rule 4. If y is equal to cos x, then divide the x is equal to minus sine x. Please write this down also. Rule 5. If y is equal to exponential x. Exponential means natural exponential, which is this e here is a constant value. 2.718 is the value for e. So this is 2.718 raised to the power x. So divide the x of natural exponential is equal to e raised to the power x, exponential x. We will still get the same thing. If y is equal to exponential x, then divide the x is equal to exponential x. Okay, rule 6. This is where we get serious. The product rule. Differentiation of products of functions. So this rule it's quite simple. If y is equal to u times v, where u and v are functions of x, so we are now saying that y is a function of a function which is dependent on x. Y is a function of a function which is dependent on x, and the two functions are multiplying each other. This is what we call the product rule. Then divide the x of this particular expression is going to be equal to u divided the x, or divided the x times u divided the x, that's u times divided the x, plus v du dx. What that means, first one, keep u constant and use it to multiply with the derivative of v. Then add the next step to it. Keep v constant and then use it to multiply the derivative of u with respect to x. So let us try an example using this formula then. if we have that y is equal to x is to the power 3 sine x, what is the y dx? If y is equal to x to the power 3 sine x, what is the y dx? In this case, let us split functions into u and v as we stated earlier. We have x to the power 3 and then we have sine x. So this is in the form of u dot v. X to the power 3 is one function and sine x is another function with respect to x. So u will be equal to x to the power 3. The next important thing we need is the u. The u is going to be equal to, based on our second rule of derivative, the u dx will be equal to 3x squared. And then v is going to be equal to sine x. And the v is going to be equal to, from our third rule, the v is going to be equal to cos x. Good. Now that we've simplified this, let's put it into our formula for the y dx of the product rule. So the y dx in this case is going to be equal to u dv dx, that is x to the power 3 times dv dx times cos x. This is dv dx equal to cos x. So that's going to be x to the power 3 times cos x plus du dx is 3x squared, and then v is sine x. So we said plus v du dx. So v is equal to sine x times du dx. Du dx is 3x squared. That will be times 3x squared. So we can simplify this. I can see from my expression above, or from my equation above, that x squared is common here. So if I factor out x squared, I would have x squared coming out. So I will have the y dx will be equal to x squared into brackets. If I bring out x squared, based on the law of indices, I would have an x remaining there. So that will be x cos x plus, if I bring out x squared from here, I will have 3 sine x plus 3 sine x. That's easy. Okay, so please try to do 1 or 2 examples on the product rule and then leave your comments in the comments section, and I will attend to them if you have any challenges. Okay,